So for this video, we're just going to go over a few more examples of proving triangles are congruent. Um, but these are going to take a little bit more thought. As you can see here, we're not going to prove triangles are congruent for our final step. We're going to prove that angle R is congruent to angle T. But you'll see in order to do that, along the way, we're going to need to prove that triangles are congruent. So let's check it out. So we're going to draw it. There it is. And then we're going to mark it. So angle 4 is equal to angle 6. So we got angle 4, angle 6. Angle 1 is congruent to angle 3. Angle 1 is congruent to angle 3. So we should have 2. Angle 4 is congruent to angle 5. So since angle 4 is congruent to 6, it's also congruent to 5. Okay, now it says prove that angle R is congruent. This angle R is congruent to angle T. So in order to do that, if you take a look at it, you'll see that we're going to have to prove that this triangle here, PQR, is congruent to this triangle here, QST. I'll do that in a different color. We have those two triangles being congruent, and by that we could say, okay, well then these have to be congruent. Okay? So now that I've got a bunch of crazy drawings on there, let's try it. Okay, so the first thing we should notice is that we only know angles. We only know angles. And knowing that all the angles are congruent isn't enough to say that the triangles are congruent. We could say that they're similar, but unless we know something about a side, we don't know anything more than that. They could be similar, they could be congruent. So we need to know a side. So what information can I get out of here, even though it only talks about angles, that could help me say something about a side of this? A side of these two triangles. So remember, we're looking at PQR and SQT. There's two triangles. Well, you can notice that we have a triangle here, QPS, and it has two congruent angles here at the base. What does that mean? That means that PQ and QS must be congruent because this is an isosceles triangle. An isosceles triangle has two congruent angles at the base, which means these two sides are congruent. So I'm first going to have to state that. We'll say angle 4 is congruent to angle 6 is given. So triangle PQS is, since that's isosceles, then we know that PQ is congruent to SQ because of the definition of isosceles. So we're one step closer here. We can then say, okay, now I know that I have an angle and then a side. I have an angle and then a side. So if I have an angle and a side, I should look for either this side. So can I prove that PR is congruent to ST? It doesn't look like it. But I have, let's see, angle, side, and I have an angle here. See, I have an angle, a side, and I have part of an angle here. So can I prove that this angle is congruent to this whole angle. That's what I have to look at. So I think you can here, because this angle here, angle PQR, is angle 1 and angle 2. So angle 1 plus angle 2 makes up PQR. This angle here, SQT, which is the corresponding angle, is angle 3 plus angle 2. Since we know that angle 1 is congruent to angle 3, which is given, we will say angle 1 is congruent to angle 3 is given. So these are equal and these are equal, so both of these have to be equal. Then we'll say angle 1 plus angle 2 equals angle 3 plus angle 2. So angle PQR equals angle SQT. Take a moment to let that sink in there. If these are the same and these are the same, then adding them together must be the same, right? This whole thing is equal to this whole thing. So then these two are equal. Because really, if this is equal to this, and we're just adding 2 to it, we have 1 and 2 added together. It's going to be the same as 3 and 2 added together. So I will erase all that confusing stuff. I have all the necessary information to say triangle PQR is congruent to triangle SQT by angle, side, angle. I have angle 4 this side and angle PQR, this whole thing. I have angle 5 congruent to angle 4, this side congruent to this side, and this whole angle congruent to this whole angle. So angle, side, angle. And I'm not done though, because we're not trying to prove they're congruent. We're trying to prove that angle R is congruent to angle T. But since I know this, I can say in my final step, then angle R is congruent to angle T by CPCTC. What does that mean? That means corresponding parts of congruent triangles are congruent. What does that mean? That means since I know that this triangle and this triangle are congruent, then I know all the corresponding parts are congruent. Corresponding, of course, means that the ones that go together. So T and R are congruent, S and P are congruent, and 2, 3, that one is congruent to this one. They overlap. And you know all the sides are congruent as well. All corresponding parts of congruent triangles are congruent. So we know, since these triangles are congruent, that angle R is congruent to angle T, and we're good.